Afternoon. So someone just came to me in the office hours and asked about a quiz question. So this was question 7 in today's quiz, and said what gives that the question had the wrong answer. So the question was, why is it better to use comparable of country than it is to use comparable? And so we'll get to that during the lecture, and I'll answer the question again. And so the person said, well, I remember it says in your slides, it says no cast is required. And that is very true. It does say so in the slides. And at one point I considered making that the right option, but then I couldn't think of reasonable wrong options. So I was mean, and what I then said here is no cast is required when the country class is instantiated. And so that was there to make this a wrong answer. What does it mean for a class to be instantiated? To construct an object of that class. So when you say new country, that means to instantiate the class. Well, of course, no cast is ever required when you instantiate a class, because when you instantiate the class, that just means you call its constructor, and you don't ever cast, when you call the constructor. You might want to cast what comes out of it or something, but in the instantiation itself, no cast is ever required. So that couldn't have been the reason it was better. We'll see in a few minutes why using the generic interface, why it makes the comparative method easier to implement. So I do realize that was not nice. So that'll happen once in a while, and that's not a problem. If you lose 1 point in a quiz, that's what 300 points total over the semester, just about. So it's not a big deal. But by all means, feel free to ask in Piazza. So the student who came to me said, well, gosh, if I bring this question up to Piazza, I'll give away the answer, but I don't care. So if it's a quiz question and you're confused about a quiz question and you say, I answered this and it was wrong, I'm perfectly happy to have an answer about one question per quiz on Piazza. If it goes on with every single question and so one could from there construct the solution of the quiz, then that would be going a little far, and I would start putting a break on it. But if there's a tricky question that really confused you, by all means ask it on Piazza. If it confused you, it probably confused a whole bunch of other people, which was the case with this question, because the next person who came in said, oh yeah, I was confused about that question too. So I'd rather have you be unconfused and know and think about it. These quizzes are meant to make you think, to give you some feedback, have you done your pre-class reading to the degree that you can follow the lecture, and do you know the basic stuff. And if for whatever reason that is not so, by all means complain. Any other question that you have right now in your mind? Okay, I had one other really good question from a student who came by in the office hour, so I want to quickly demonstrate that. So what this student said is, when you do these code check things, and it's a complex problem, and you don't want to do it right in the web interface, and so I thought that this student was thinking it exactly right, because when we look at one of these code check problems, we look at this. There's a whole bunch of different classes, and this is not really a good programming environment here. And so you really do want to do this kind of stuff in Eclipse. So let's do that. Let's see if I have Eclipse open. Yes. And so let me do this from scratch. So I'll just do it completely from scratch. So we'll make a new project, and Now, this is a brand new project with no files from anywhere. So in this case, it's fair to use the default location in the workspace to put the project there. There's unfortunately no really good way of downloading all those files into like a stored project. That may happen at some point in the history of CodeCheck, but not yet. So we'll give it a name. What was it? Homework to be draft. So now we'll make a new class inside here. And now when you look at this thing here, it does something that is a little unhappy. So I want to copy and paste these things. Now let me put this on. So let me do this again. New class. So I want to like copy and paste the square sequence and the same thing with the other ones. And so I'll say name square sequence. Now what's going to go wrong? Okay, I didn't know that either, so I'll make it go wrong so you see what happens when you do. Notice this thing here? So it put this in a package. Now, unfortunately, CodeCheck doesn't like packages. Packages are certainly a good idea. And starting next semester, when your projects get to be too big for CodeCheck, you will be always using packages. But right now, we're not yet at that point, so we're not yet using packages. Eclipse, being an environment for professionals, they say, everything should be in a package, so we'll start with something. So there's two ways of overcoming that. First one is you could take this thing and move it into the default package. So if you just drag it here, then it does that. Unfortunately, it still leaves it here, so I could now kill this package. The other way you can do it is when you say new class. You can pay attention to this line here where it says package, and you can delete it. And then you get a little thing here that says the use of the default package is discouraged, now, which in general is very good advice. But for this semester, we still do all our work in the default package. So those are one of the two ways you can do it. You can have it make the package and then later move it around, or you can just erase it right here. That only happens when you make a new project without existing sources and you make these sources in this way. Of course, these sources are now useless and you have to copy and paste from here. Here's random sequence. And so I realized that this is some annoying hassle, and maybe I'll get around to giving you a link at some point where you could just download all these files at once. Only for a complex project like this is this an issue. So be aware of these packages. If, God forbid, you submit something with packages to CodeCheck, it will fail. It'll just not, and you'll notice because you will not get any points. And then you have to take out the packages again. That's another way you could do it. You could solve your problem with packages at home, and then when you copy and paste, you would just have to be careful to skip that one line on top that has the package name. That'll also work. So think of some way that you do that. It is a good idea once it gets complicated to do your solution to the degree that you can at home in Eclipse. And with some projects, with some assignments, it works better than with others. And I'll try to make that process a little easier, like I say, but no promises when. The final thing is, I've had a small number of people who got themselves in trouble and got 0 points. What they did is, when they downloaded that signed zip file, the one that comes from here. So, what I said is you should always right-click and then do the save as, or here it's save link target as. And what they did is something, and maybe their computer unzipped it for them, and then they re-zipped it, or they unzipped it and maybe edited some of the files and re-zipped it. And if you do any of that, the grading part, the software that the graders operate, notices that the signature no longer works. And in that case, there's an automatic 0. This time there were 4 students in that situation, and the grader regraded them by hand. But from now on, that'll never happen again. So don't monkey with those signatures. The presumption is that the reason it doesn't do that is it would be an easy matter for you to go into the report.html and change all of those nifty fails to pass. And so the signature then would no longer match. And that's what the signature is there for. You had a question about that?
So we click download, we just submit the file, we download.
Yes. So you say save as, and then, like I said before, the best thing you can do is set up already a hierarchy of the problems. That way you'll never have a conflict with file names.
Okay. So for O'Brien, she has file.
Don't change that file name.
Okay.
Don't touch the file name. You just don't know what that automatic system is going to do with these things. And so far, you don't look too unhappy, so it must have worked, but it might not work next week. So don't monkey with these file names. Take them exactly like they are. Make sure that they're not unzipped. Make sure there's no _1 or dash whatever attached to them. Just save them exactly the way. And so someone said, should I do this in the virtual machine? That is probably a very good idea, because the operating system in the virtual machine is Linux, and so that's not a system that's been, what's the polite way of saying dumbed down, for casual users. So Linux does not generally do such things as automatically unzipping stuff that shouldn't be unzipped or renaming things. So that's always a good remedy, or you could just learn how to avoid these things in your day-to-day operating system. All right, so those are the 2 things that I wanted to talk about before starting with the lecture. Were there any other questions? Yes? I'm sorry?
What do you mean by signature? You said that was signature.
Well, so there's a way of what's called digitally signing documents, and so what it involves is there's a secret key on the server that you don't have access to, and so that's used to embed a signature into the zip file. The grading software has the matching, what's called the public key, and it'll check that the signature corresponds to the contents of the zip file. So if you were to unzip the file, change a few of the fails to pass, and re-zip it, then the signature would no longer match. And there's no way for you to recompute it without having that secret key. And so that's what it's there for. So if you don't touch those zip files, if you never open and re-zip them, there's not a problem. But once you open and re-zip them, if you make no changes, it should still work, but if you make any changes, it will not work. So don't touch them. You can look at them with the file browser, but make sure they don't get unzipped. All right, let's move on with the lecture. So we talked about measurable, and I told you that measurable was kind of a toy type that was designed for the book, to give an easy example of interfaces. But I want to talk about the comparable type today, because that's one that's used very, very often in Java. And it's kind of similar, but it is more complex. And so it's a good idea to have seen measurable first. So it's very common that you want to compare things. When I first started as a computer science student, at the time my professor said that 95% of all software that runs does sorting. Today that's no longer true, but at the time that probably was true. Most of the software was business software, that dealt with databases, and it had to do a lot of sorting. So it had to arrange things in sorted order. So, when you want to arrange strings in sorted order, there is what's called the dictionary order. And so, hello comes before hill, because the E here comes before the I. here you have a word that's just like hello but shorter, and so that comes before hello. So shorter words come before longer words, and when the words differ somewhere, then the first position at which they differ determines which ones comes first. I mean, that's anyone who uses a dictionary, that's second nature to them. Now, this kind of comparison is not the same thing as measuring. If you can measure something, then you can compare. You can see, does it have a lesser measure? But with the strings, there would be no measure that gives you, or at least no obvious measure, that gives you this ordering. So strings are comparable, but they're not necessarily measurable. If you were to measure them by something, you would probably measure them by length or number of vowels or something, and that would not give you the same thing as the dictionary order at all. So the dictionary order is a different kind of thing than anything that you can obtain from a measure, and that's what the comparable interface is there to do. So the comparable interface has a single method called comparator, and just like the measurable interface has a single method called getMeasure. Now, to measure something, you only look at the thing that you want to measure. The measure of a country, you just look at that one country. But if you want to compare two things, you compare two things, so you need to look at the thing and another one. And so that's why comparator has this extra parameter. So when you call a dot comparator of b, you compare a and b, and the a is to the left of the dot. That's the first thing that you compare, and the second thing that you compare goes inside the parentheses here. So the comparator method takes a parameter. Unlike when you measure something, you would just say a dot get measure, and there's no second parameter. Now that parameter gets us into a bit of hot water. So what we would ideally like, if we compare two countries, for example, we would like to compare a country with another country. When I compare two bank accounts, I would like to compare a bank account with another bank account, and so on. So I would like the type of this thing to be country or bank account or whatever, but that's not so easy to arrange. And with the Java that you know so far, there's in fact no good way of doing it, and that's why we use the word object here. Because otherwise there would be no specific type that we can use. So so that's one of the things that we're going to be struggling with, that the other object comes in as an object. Now there's an int here, and the significance of this thing is it returns some negative value if a is less than b, when you call a dot compare to b. It returns a positive value if a is greater than b, and it returns 0 if they are the same. The negative value may or may not be -1. Many times it is -1, but it isn't always -1, because sometimes it's easy to generate any old negative value or positive value by doing a subtraction. Let's suppose, for example, that we have a class person, and it implements comparable. And we have an ID. Now, one way that it can compare things is I can compute a.id minus b.id. And this would now be a negative number if the ID of A is less than the ID of B. And it would be a positive number if A has an ID that's bigger than B's, and 0 if they're identical. And so that saves us a couple of lines of code to compute that difference, and there's nothing wrong with it, and that's why this int could be absolutely anything. Only the sign of it matters. You don't normally care much about it because most students don't do this. Most students always return -1 or 0 or +1, and there's nothing wrong with it. The only time that it gets you in trouble is if you check explicitly if the comparator returns a -1. That would be wrong, because it's allowed to return any negative number or positive number. All right, so these are the two wrinkles here. So here I give you an example. We want to make country comparable. And over here, I want to compare by area. So I return a -1, or a 1, or a 0, depending on whether the first area is less than, equal, or greater than the other area. So why don't I just return area minus other dot area? I don't actually know that. Oh, I do know that. Let me ask that again. So what's wrong with, why couldn't I just do that? I just sold this as a benefit and now I'm not doing it.
Area is a double.
Yes, excellent, from the gentleman on top. Area is a double, it's a floating point number, and so it's conceivable that, it's a little known fact that the areas of Monaco and Liechtenstein are less than a quarter of a square mile apart from each other. So then they would come out to be exactly the same, even though one of them is slightly smaller or slightly larger than the other. So with double, the subtraction trick never works because they could be within a half away from each other and still be different. It only works for integers, and in fact, it only works for positive integers. Otherwise, the computation might overflow. So anyway, I'm not doing it, and so I'm just explicitly doing this stuff here. There's nothing wrong. So over here, this red line here, I am taking other object and I'm casting it to country. I have to do that because over here the parameter is of type object, and an object does not have an area, right? An object could be anything, so I couldn't just do other object dot area. I have to first cast it to something that the compiler knows has an area, and in this case, of course, we expect another country. What would happen if someone compared Liechtenstein with a watermelon? So if someone compared a country with a watermelon object. Would the compiler refuse to compile the program? Sadly not, right? Because the compiler would say, oh, hey, it's passing an object. Any object is fine with me. When the program runs, would it find the area of the watermelon? What happens? You get an exception, you get a class cast exception right at this point when trying to cast the watermelon into a country. That's just the way it is. Now, the other thing that people always ask at this point, and you will, that's not now, is why do I say other dot area instead of other dot get area? And the answer is because I can. It saves me 5 characters and 1 shift key. Right? But why does it compile? Isn't it illegal to get into private instance variables? Isn't the whole point of private and public that you have to use the method to access an instance variable? It's inside the same class. So other is a country object, and we are coding this up inside the country class. So inside the country class, it is legal to look at any area field of any country object, both the implicit object as any other country object that we happen to have in our hands. So You don't have to do it like that. Feel free to call get area. It's not a big deal. But when you see this, it does compile. And I don't think it's particularly evil. All right. So now on to these generics that the quiz question was about. So this cast here is not so nice. And so there is a better way. And the better way is to learn how to work with the generic comparable interface. So you've seen generic classes before. You've seen array list. We always say array list of something. Array list of country, array list of question, and so on, with the angle brackets. And you can do the same thing with comparable. And the parameter that goes in here is a type, and that is the exact same type as the type that goes into the comparator method. So these types here need a match. That's a little different than with the array list. With the array list, this thing inside the angle brackets is the element type, the type of the things that you put into the array list. With the comparable, the type is the type that is the parameter type of comparator. So they're both variable types, but the variables are used for different purposes. All right, so let's put this to work. So here I'm doing something that, yes, let me double check for, yes. Okay, I'm going to show you the code the way it is in the book, and then as a bonus I'll show you how you can rewrite it with parameterized types. So this is code that very similar to the average method that we had for measurable, but here it is something that computes the smallest thing. So here we're putting it into an array of, we're getting an array of comparables. And if you remember from CS46A, there's a standard algorithm on how you find the minimum of an array. You first assume that the very first one that you see is the smallest. Maybe him. And then you look at the next one. Oh, he looks taller, so we continue to believe that he was the smallest. We move on. Well, he looks a little smaller, so I guess he is now the candidate smallest. He looks taller again, so in the end we say he's the smallest. Nothing wrong with being the smallest. So we have the smallest so far, and we set it to the ith value if the ith value was shorter than the one who we up to now believed to be the smallest. That's the algorithm. And so the beauty of this algorithm is it works for everything that's comparable. Once I have this algorithm implemented, I will never have to re-implement it. I can now use it for countries and for bank accounts and for strings and whatever, provided that those classes implement comparable. So here I'm using it. The string class implements comparable, and so this will give me the smallest string. Am I asking what the smallest string is? Yes. All right, so let's see what it does. Let me open up Piazza and make the question. All right. Could we accelerate this a little? Two more. One more. All right. So, oh, let's see what people answer. Wow. All right, so people are wildly divided here. So a whole bunch of people said Fred. Why Fred? Was the shortest name, eh? Or maybe you remember the Flintstones and Fred was shorter. So it's not Fred because, so when we call smallest over here, so it has an array of comparable, it calls compare to, and so let's see what happens when we call Fred dot compare to Barney. What is it? So what does this call return? It's going to return 4. Why 4? Yeah, so it looks at F, and it looks at B, it subtracts the code points, and F minus B is 4. Right? There's 4 letters between F and B, they come in linear order. And so it returns 4. And so that means that Fred is bigger than Barney. Why is Fred bigger than Barney? It's shorter. Comes later in the dictionary, right? When you look up Fred and Barney in the dictionary, Fred comes after Barney, so it's greater. So comparing of strings works in dictionary order, and so if we look at the smallest of these strings in dictionary order, it's going to be the one that we find first in the dictionary. That would be Barney. So Barney has a chance of being the right answer. But then there are these other tantalizing options that a number of you chose. The second most popular one is that the program doesn't compile. Why wouldn't it compile? Well, some of you chose it. Someone tell me why it doesn't compile. Yes?
It doesn't implement comparable.
Aha! So someone said that it doesn't compile. That's a very reasonable thing to conjecture because string doesn't implement comparable. Let's find out. So here's the string class, and let's see what it implements. All implemented interfaces, serializable, we don't know what that is. Car sequence, we don't know what that is. It does implement comparable. So string does implement comparable, and so in fact, the code will compile. Just to give you an idea how many classes implement comparable, click on comparable, and you see that there is a large number of classes that implement comparable. Comparable is in fact the single most popular interface in the known universe. There are more classes implementing comparable than there are stars in the Milky Way. So, so here are the ones in Dustin, the standard library, and so that wasn't it. So could it throw a bad cast exception? Really, there's no particular reason to believe that, because we have an array that contains 3 strings, and we don't quite know what the compare-to method does for strings, but if it were to cast something, it would cast it as a string, and so that wouldn't be going wrong. So the correct answer was, in fact, B, and so those 23 of you who got that, pat yourselves on the back. All right, moving right along. I'm not actually going to do this because, in the interest of time. So what is the advantage of the comparable interface in the util.smallest method? And so what I'm after here is, look at this method here. And I'm saying, what's so great about using comparable in here? And you know, what's my alternative? I want to compute the smallest, and I don't want to write a method that works for an array of just integers, an array of strings, or an array of bank accounts. I want it to work for the most general possible reason, because I don't ever want to write this method again in my life. And so that's the advantage of using the interface type, that I can write a single method that works for everything. That's why they built the stand mixer. Remember the stand mixer? They didn't ever want to build another kitchen machine that rotates stuff. There's one machine that rotates anything you want. You know, the beater, the whisk, your laptop with the right attachment. So you don't ever want to build another rotation machine, and that's the one machine. You don't ever want to write another time this method here, and that's the one thing. So let me just very quickly say how you would rewrite this method if you wanted to write it with the comparable of t, which would be a little nicer. Then you put a bunch of angle bracket t's in here. You will not have to do this yourself. I just want to do it there because you're going to see them once in a while in CodeCheck, for example, or in the book, and it is useful to be able to do this. So when you make a method that's supposed to work with arbitrary t's, you have to put an angle bracket t at this spot here, right before the return type. Then we wanted to work with a comparable of t, where t might be a string or whatever, and then over here we put the bracket t, and the advantage that we're getting is then we can say it returns a t. So when you compare a bunch of strings, the return will be a string, and when you compare, that means you can also put you can actually put a t, not a comparable of t. So let me take that out. So you can actually put a t here, and that makes it a little nicer. So that's just a preview of that stuff that you're going to be learning next semester, but I wanted to point that out. So the disadvantage of comparable is that a class must make the conscious decision to implement comparable, and then it only gets one shot at it. So if one wants to compare countries maybe by area or maybe by population, the country class can only do one of the two. If you wanted to sort strings, sometimes in dictionary order and sometimes by length, you can only do it one way. And actually, when you think about it, it's not very common in a business application to use dictionary order. In a business application, you would want to use some order that follows the conventions of the country that the people live in. and in different countries, they actually sort strings differently. For example, in Sweden, and I'm not making this up, unlike some of the other things that I tell you. In Sweden, you have a few extra letters, and you have a letter like an A with the 2 dots, and it comes after the Z. So in a Swedish dictionary or in a Swedish telephone book, if your name starts with an A with 2 dots, it comes after the Z, and so they will then have to sort strings in a different way. Whereas, of course, in English, if someone has a bunch of dots over their letters, it makes no difference. Those of you who have like Spanish names or French names perfectly well know that those are pretty much ignored when it comes to sorting. So, so it is common to have even an array of strings and want to sort it in different ways. And in order to do that, one needs some other way of specifying the comparison. And so this is done with these callback objects, with these comparators. So here I have a class, have an interface comparator, and that gets implemented with a method that compares arbitrary objects, or if I prefer, I could. There's a generic version of it where one can specify the object type. So here I give an example of a comparator, and without the generics to keep it simple. So here I have a compare method that compares 2 countries. Unfortunately, I get them as objects, so I cast them as country. And now I compare the countries by name. The first name is a string, the second name is a string, and I compare these strings using the string comparator method. So this here is the method of the string class. And that way I would get, like Belgium would come before USA. Even though clearly Belgium is smaller, but here we're comparing them by dictionary order of their names. So this method itself is not too surprising, except maybe for the casts, which are necessary because the things come in as objects. It simply does what we promised to do. It compares 2 countries. So what's funny is you have to put it into a class. You have to give the class some name, and so that's why I give this lengthy name. And you want it to implement comparator. Now what can you do with it? You can pass it to a method that knows something about comparators. And so the method that we're interested here is, is arrays.sort. So there's a utility class called arrays that's pretty similar to like the class util or data that we've been using for the fake examples in the book and in the lecture, but this is a genuine class that comes with the JDK. So all of these methods here are ready for you to use. So when I had my first job interview, 20 some years ago, someone asked me how to sort an array. I thought it was the dumbest question ever. I told him to use the library sort, and I didn't get hired. But I'm glad I didn't take that job. You wouldn't want to work for a company where they want you to tell them how to sort things. So there is a sorting method here, and the one that we're after here is this one here. It takes an array, and it takes a comparator. And so it's going to use that comparator to sort the array. If you have an array of countries and a comparator that compares them in some way, like the one that we just had where it compares them by name, then it'll sort the array of countries in that particular way. You want to sort them differently, you pass a different comparator. So this is a beautiful, very general purpose method. Anything that you would ever want to sort that you already have in an array, you make a comparator, you implement the comparator method so that it does the sorting the way you want it, and then you call arrays.sort. So paradoxically, in 46B, you're going to be learning how a sorting algorithm is actually implemented and which ways are better implementations than others, but you'll never actually in your professional life use any of the ones. That's just so that you know what goes on under the hood. So anyone who wants to sort, calls this sorting method. All right, so with that background, let's look at this clicker question here. So I'm asking you, how do you now do this? You have an array of countries, you want to compare them by name. So pick the right syntax, and I will open up the question. Yeah, almost there. Wow, okay. So, now let's see how people voted. And so the majority opinion is 3 with 2 close. Okay, so most people chose C, and the second most popular was B, and it makes sense that the other ones were pretty much rejected because, you know, this is clearly not very good because arrays does not have a method, country comparator by name. Now, arrays is a utility class. Why would it have that method? The method was called arrays.sort, and so it must be one of these 3. Now, this one here is wrong because arrays.sort has 2 parameters. If you look at arrays.sort, the first parameter is the array A, and the second parameter is the comparator. The comparator C. So it has 2 parameters. So we are down to options B and C. Now, this one here is the name of a class. And so you cannot pass the name of a class as a parameter. You can only pass an object to a method. You can't pass the name of a class. So this can't be right. And so this, by elimination, we have now narrowed down to C. Was that the majority answer? And it was. All right. Now, the problem for the programmer is that indeed we do need to make an object of this class, and that's what makes it a little bit tedious to use these interfaces such as comparator. Comparator is a beautiful interface. It makes it possible for us to do arbitrary comparisons, but it's a bit of work. You have to write the compare method. If you don't use generics, you have to do the casting, which is an added burden. You have to put it in a class, which is a real hassle because you have to come up with this class, and then you have to make an object of this class. So there's three things you have to do. Is write the method, write the class, and make an object of that class. And the last two are really busy work. That's because the way that Java is, that in Java, every method needs to live in a class. And to do anything with a class, you have to have an object. Java is an object-oriented programming language. There are other programming languages where you can just write a method, and it sits there all by itself. It's something that you can use. Java is not among them, so it makes you do this extra busy work. But I'll have a little bit more to say about that at the end of the lecture. All right. So here's the implementation of smallest using the comparator, by the way. So if I want to have a smallest that works completely general, then in this case I'm not relying on the fact that these objects are comparable. They could be any old objects, comparable or not. I'm getting a comparator, and when I implement my own utility method here, then I just use the comparator that was handed to me, and I say, hey, you comparator, you know how to compare two values, so go for it and do that comparison. Okay, do you want to talk about inner classes? Okay, I'll talk about it very briefly, because it is sometimes handy, and we run into them once in a while. So here we have a class, and you see inside that class we define another class. So far you've never done that, but it is entirely legal in Java, and you can, in fact, even inside this inner class you could define an even inner class. Why would you want to do that? And you normally want to do that because you have some small helper class that you don't want the world at large to know about. If it's a class that you only use once. So far you haven't really had a reason to have a class that you only use once, but these tactical classes that you use for implementing comparator, for example, you may never want to use them again. You may just once make this comparison, then you don't care anymore. So these are often done as inner classes. And so you'll see that once in a while in the book. So you can even do this inside a method. So inside the main method, you can define a class that you don't care to use anywhere else, and then you have it here. It's called an inner class. So here's an example where I'm making a comparator as an inner class. I put it inside the main method, and I call arrays.sort with that. And that's just the way it is to keep the program less cluttered. That way on the top level in Eclipse, for example, you don't see that class that you only need once. You just hide it in here. It's not a really super significant concept. It's just a minor way of organizing your code so that to remove clutter. You can, in fact, do even better than that. You can give the class no name. And I'm going to show that very briefly because this is something that was very popular a few years ago, and there's now a new feature in Java that makes it less popular. So here I have this comparator. Look at this comparator here, the length comparator. So I make a class, and then over here I make an object of that class. The compare method compares by length. And now I say, gosh, I'm only going to use this class once. I don't even want to give it a name, because in general, when you use something only once, you don't give it a name. For example, suppose you wanted to compute 2 times x. Would you say int factor equals 2 and then factor times x? That sounds crazy, right? Why give it a name if you don't have to give it a name? You can just use the value 2. If you only use it once. If it's a constant that's used many times, you might give it a name. But if it's only used once, people don't like to give it a name. You know, it's just when you meet someone only once, you would just say, hey, you, and you don't really care to know that person's name. All right, so how can we do that with classes? The way it works is like this. So here, this thing is an object of a class with no name. So the new tells you it's an object, and the class has no name. The name was omitted from here. Before we said length comparator implements comparator. Here we are omitting the length comparator implements. We just have the name of the interface. And then we follow that by these here. These are the construction parameters. So this is a strange syntax for making what's called anonymous classes. So when you see new followed by an interface, it couldn't possibly mean a new comparator. Comparator is an interface. You can't make an object of an interface. Yes?
Can you just write new and then brackets and then
No. So you have to give an interface. Yes. So it has to be new and the name of an interface or a superclass. And what that then means, if you say new followed by the name of an interface or a superclass and then the parentheses, that means make a new object of a class that doesn't deserve a name, that implements this interface, and whose method is whatever is inside here. So you're going to be seeing this probably in 151 unless they update the textbook. It's a common thing for these kinds of utility throwaway classes, and they're called anonymous classes. So just as a prefix of what you'll see. Do I want to do this? No. Oh no, I do want to do this because this comes from the lab. Yes. So in the lab, in lab number 1, there was an ArrayList address book. And the ArrayList address book had a challenge that it had to collect not just one thing, it had to collect 3 things together, namely the name and then the key, which was either phone or email, and the value, which was the phone number or the email address of these professors in the department dictionary. You remember that from the lab. And you wanted to stuff them all in an array list. I guess it could have made 3 array lists in parallel, one containing all the names and one all the keys and one all of the values, but that's kind of icky. So in object-oriented design, you say you want objects and classes. So it made an array list of items, where an item has a name, key, and a value. And it stuck those in. This item class was a private class. That's how it was. Did anyone notice this, by the way, in the lab? No? So let me pull up the lab because everyone's eyes are glazing over here. So this was lab 1. Here it is. Oh, that's why everyone's eyes are glazing over, because it was not the case. So someone changed the lab, and didn't tell me, and made item into a public class. So never mind, I retract everything I said. So assume for a minute it had been done. So no wonder everyone was looking like that. So work with me. So we're going to change the item, and we're going to make it into a private class here. Okay, exactly the way I say here. And now go ahead and answer this question. Let me make the question as clicker question 4. Yes?
So when you do these inner classes, is it like a waste of, like, let's say you're not using one, you have like a class that you're always instantiating, then it has inner classes, and you're putting thousands.
So your question is, so in this case here, when I'm, whether if I make an array list address book, like, do I also make the inner class?
Yeah, so this example, like, if you make like a million array list address books, we're making that inner class like take more memory, so just make it a separate class.
I see. And the answer is no. So there's no difference in memory. It's only a question of who can access this class. So if I move it inside or if I move it outside, from a memory point of view, it has no impact whatsoever. Either way, there's this class and that class. It's only a question of accessibility. Who can see that class? So classes are not objects. So when you define a class, it's potentially a factory for making objects. But so there's no connection between how many objects of this class and how many objects of this class there are. So if you have a million array list address books, you will, as a practical matter, because each array list address book will have a whole bunch of items in it, you'll probably have more than a million items, but you will not have more than a million item classes. There's only one item class. So the class is just one thing. So if you have a million address books, you have one class array list address book, and you have one class array list address book dot item. And so there's absolutely no waste. You don't look convinced.
I think I got it, yeah.
All right, and you got us almost over vote threshold here. All right, so let's see what people are voting for. Okay, almost everyone said 1, and that is good. Okay, so all methods of the array list address book class can construct and access item objects. Well, that's got to be true, right? Because the class is defined here. And why wouldn't they be able to, right? It's inside array list address book, so surely they can do this. And it is in fact true, so the only thing we want to watch out for is to see if I messed up and accidentally put in 2 right answers, which I sometimes do, or sometimes on purpose to increase general confusion. So let's see, here it says any code outside the array list address book class refers to this class in here as array list address book dot item. Isn't that true though? That should be totally true. Yes? Aha! It is private. So that means no one outside array list address book can refer to this class. It's a private feature of array list address. So only because it's private is 2 false. If it was public or nothing, then 2 would be true. That's how, in fact, someone would refer to it, but because it's private, no one else knows about this class. These private inner classes are also kind of common, that when you have a data structure, and we'll see many more of those later in the course, then this is in fact what happens. So what about 3? I was sure that lots of people would vote for 3 because the instance variables here, look, they're not private. There's no private, no private. Many people got points off in homework 1 because they didn't put private in the instance variables. Why is it okay for item not to have the instance variables private? Because all of item is already private. So, it's not okay for you to run around naked, but what you do in your own bathroom, no one cares, right? So that's how private works. All right, and 4 is just because I couldn't think of another distractor, and it didn't fool very many people. Mock objects. This is something that you're going to be seeing in another lab, where in the lab that you had so far, there was this array list address book, and then there was the address book interface. And you may wonder, why torture us with the interface and the class when one could have just used the class? But interfaces are great when it comes to testing. Now, I agree that array list address book was not the most complicated class ever, but these classes are going to get more complicated. And let's say you want to test something. Then there is a very nice testing strategy that's called mock objects, where you say you have a complicated thing that you want to implement, and at the same time, you want other people to write test code for it. You may want to have other people who already start using the thing, even though it hasn't been fully implemented. And the following tricks makes that possible. You come up with an interface that has all the methods of your service. You have your class, of course, like the array list address book, implement all of these methods. Programmer A goes in a corner and does all of that. But before that, we also make a mock implementation that implements all of these methods in a trivial way. So we're making it so that get always returns Fred. So this class compiles and it runs, and when you ask it about any property at all, it says Fred. And that means that someone else can already start putting that into their code. Maybe they're working on the user interface. And of course, in the user interface, no matter what question the user asks, it's going to say Fred. But the other person can put up buttons and text fields and whatever, and can already start working. One can see whether the testing code works and stuff. So it's a great thing for teamwork. Eventually, programmer A is done, and then programmer B simply changes this line to that line, and then they get the real address book that does all of things. So that's a good way of using interfaces, and you're going to be seeing that various times during the course. So that's what mock objects are. So I just want to advertise that. So I want to give a super quick bonus thing here. And that is, I've told you at great length about these comparators and the measurers and all of that. And I've spent more time than I might have because Java has now changed to make them much, much easier to use. This is not yet part of the book, and it's not part of the official course, but you may just enjoy doing that because it saves you lines and lines of code. So go ahead and do this whenever you want to. You will never get penalized for doing it the smarter way. But on the other hand, if it blows your mind right now, you can't just wait until inspiration strikes later. So the idea is when you have an interface such as comparator that only has one method, then there is now a great shortcut to make the method, the class that implements the interface, and the object of the class that implements the interface. And it looks like this. You say, I want a comparator. It takes two strings, and it returns the difference in length. That's how you write it. This line is the same thing as these lines, or God forbid, these lines and this one. So that's clearly desirable, and it's actually pretty simple to do. And so when you call methods like arrays.sort, then you can just pass this thing. So this says, let's sort the words array, whereas the comparator, we use this guy here. And so at this point, arrays.sort becomes super attractive. Now you no longer have to make a class and an object. You simply pass the thing that's used for comparison. You have to learn the syntax, where over here you have the parameter types, you have an arrow, and then here you have the return value. But that's just syntax, someone learns it quickly. Let's see, how quickly? I guess not that quickly. All right, well, since this thing is broken, I'll fix it and then you can do it at home. That's so sad. So before next class, so there's no class on Monday because of Labor Day. There is still a homework on Tuesday because Tuesday is not Labor Day. So there is another draft due on Tuesday that doesn't require any more than what you know as of today. But there is no quiz on Monday either.